Good afternoon. Today we are going to see a different case study on sensitization. So here the sensitization actually occurs at the stainless steel. So this particular case study is about sensitization that sensitization induced stress corrosion failure on a furnace tube. Okay. So actually we will say once a furnace tube we say then we will come into mind and say this occurs at the high temperature. So we say it is a creep failure, but it is not a creep failure. It is due to the stress corrosion cracking that is induced due to the sensitization. Okay.
So here's the introduction. Alternate stainless steel are used as a furnace tubes in petrochemical industries mainly because of their corrosion resistance. Why? Because petroleum reacted towards the high temperature as well. So people are using corrosion resistance and highly mechanical strength properties in mostly petrochemical industries. From there, AISI 347 grade stainless steels are mostly used in furnace heater tubes because of high temperature, which we have mentioned before. So here's a sensitization. The main thing, it means the critical temperature between 500 to 800 degrees Celsius for a reasonable time. It means that if people are mentioning some temperature, it reaches at a particular time, right? So formation of chromium carbates, where here is the chromium carbate, the carbon which absorbs the chromium content from the particular material to attain certain grain boundaries, like which we have mentioned here, and the depletion of chromium adjacent to it means carbon. It's known as sensitization.
So add to this here as our friend said, at the temperature of about 500 to 800 degrees Celsius, the carbon which is in the material will absorb the chromium and it forms the chromium carbonate at the grain boundaries. So this phenomenon is known as sensitization. Okay.
Coming to the visual inspection, the crack is stopped at the welded stud. While the crack is started in propagation, the crack stops in the welded stud, and we can see the major two cracks. The two cracks are in diameter, in length of one is 20 mm and the other one is 18 mm. And there is an oxidation takes place, so there is no thicker scales. And this is the area where the crack happens, outer surface.
So coming to visual inspection in inner surface. So in inner surface the tube reveal presence of other hand layer of porous, may get porous, cracked or a black cloud deposit in 5 inch width. 5 inch width. Okay. Crackers are actually below the layers as put made out visually. Okay. No deep pits, there will no very deep pits, so we can visible to see the naked eye. So you can see there is an inner release.
When it comes to XRD, the strong tube at peak and D values indicates that graphite and sulfur oxide compounds are being presented identified. This is the peak of the analysis of X-ray diffraction. That's the peak points, and the graphite, sulfur oxide, and austenite are identified in this analysis. When it comes to the chemical composition, the observed values have been almost equal to A+, right? And the carbon content is slightly higher, and niobium content is slightly lower than the level specified for the steel.
Coming to the chromatography, we can see the metal granules are in the picture 1 and the microcracks in the picture 2 visibly. Coming upon the metrology, in the inner walls we can see some corrosions and inner crack in the wall and multiple cracks travels towards the view. You can see the intergranular crack on the picture A and the corrosion field at picture B, and you can see the corrosion propagation travels towards the direction and the sensitivated nature range and boundary marked to the bits on the structures on the picture C. Okay, as added to the point C, in this as often say, this is the intergranular cracking that is travel towards the grains. Second one is this is the corrosion that happens due to through the crack propagate area. And as our Harigaran said, this is the sensitized area. So you can see that there are thicker grain boundaries, which is due to the sensitization, that is due to the formation of chromium carbide, where carbon takes the chromium, so it will deplete the chromium. Once the chromium is getting depleted, corrosion increases. So these are interlinked. Once the chromium, so at a particular temperature, when the carbon takes the chromium, forms chromium carbide, there sensitization occurs. From this sensitization, will help to form the corrosion. So this corrosion will induce and form the intergranular cracking.